Welcome. So in this lecture, I would like to kind of set up clearly the relationship, really between antiderivatives, definite integrals, and indefinite integrals. So we're going to start out, so big f of x is going to be the antiderivative of little f of x, meaning that if I take the derivative of big f of x, I'm going to get little f of x. So an example we can use throughout is we're going to have big f of x equals 2 e to the 3x. If I take the derivative of that, because of the chain rule, I end up getting 2 times 3, because 3 is the derivative of 3x. So 2 times 3, e to the 3x, which is 6 e to the 3x. So we've checked it works. Okay. So, and for this to be more general, you should actually have a plus c. This is kind of a specific antiderivative. So why don't I actually write, I'm going to write the indefinite integral over here. So we have the indefinite integral. Right. So for the indefinite integral, if I take the integral of this f of x, dx, then I'm going to get this antiderivative, right? So I'm going to get f of x plus c, okay? And this is a family of functions. Right? Where I get a different function for each value of c. So if I want a specific function, I need to solve for this c, okay? And like use initial conditions to solve for this, okay? So to solve for, to get a specific function, I must solve for, and this is where we would use initial conditions or some specific values. Okay, so in our example up here, what does that look like? So we're taking, when we have the integral of 6e to the 3x dx, right, that this is going to equal, we just need to take our antiderivative from up there, so we have 2e to the 3x plus c, right? Okay, and then if I wanted the definite integral, okay, so in this circumstance, this is where I have bounds. So I'm going to take the integral of f of x dx, but I'm going to have these bounds, and this is just for my own happiness in life, that this yellow is actually different than that green. It may not appear that way. Okay, from this a to b, actually I am going to put some, it's going to be highlighted in blue. I don't know how well you can actually see that, but it makes me a little happier. Okay, so then this is going to equal, and now I've got that same antiderivative from over there, so this is going to equal the same antiderivative, but now I'm going to subtract the values that that antiderivative is going to take at my two bounds. So this is kind of a, so these are my bounds, so this is the a down here, that's the b from up there. And I don't believe that you can necessarily see that, so that's just my highlighting of this A and this B. Okay? Great. Now, this is a number. So in the case of the indefinite integral, I got a family of functions. If I solve for the c, I got a specific function. Here, this is a number. Okay. And then there's a relationship. Oh, and now let's use our same example before. So now I'm going to take the integral of, and let's go just from 1 to 2. Why not? So this is going to go from 1 to 2. Okay. Oh, you can actually kind of see that. And then our function, 6e to the 3x. And we don't forget our dx. It tells us what we're integrating with respect to. Okay, and this is going to equal. And then we have, so the way to do it, remember, is, so I kind of write this thing twice. And it helps to start out just by putting parentheses there. And then I put the top one in first and then the bottom one in second. So it's a 2, and this is my 1 for that. Okay? And so, and then if you kind of care, you can see this is actually a number. Which number is it? It's 2 times, so this is a 6 and a 3. So it's 2, and then we have 2 different powers of e, so you can't so much combine them. You kind of can, but mostly that would kind of be your answer, which is a value, a number. So we're kind of happy with that. And this here is our family of functions, right? Okay, and then you might want to know the relationship. Okay, so we have the integral from a to b. Oh, you can see that. Of f of x dx is going to equal the integral of f of x dx. Right? Evaluated, and now, so this is going to give me the family of function, or yeah, this is going to give me the antiderivatives, and I'm going to evaluate it from x equals a to x equals b. Okay, kind of like what I did up here throughout that, right? So this integral was this one, right? I took the 2e to the 3x, and then I evaluated it at 2 and 1. You may get a little confused because it's like, oh, but you dropped the c. I dropped the c is not actually important, because otherwise I would get, if I had a plus c here and a plus c, then I would get c minus c, and that would end up giving me 0. Okay, so it doesn't actually matter that I dropped the c, but this is kind of the relationship between the two sides. Maybe, and I'll put a box over around it just to kind of highlight. Okay, great. I thought it's usually good as you're introducing all these things and they're very connected to kind of show in one place the relationship, like what each of them is, the relationship. Also to keep in mind what kind of object they are, because it can get easy when there's so many different objects floating around. You're like, wait, am I supposed to have a number? Am I supposed to have a function? How do I get a function? All these kinds of things. So hopefully this kind of maps it all out very clearly for you. And I will see you in the next lecture.